2.1e, we're going to approximately locate the median and the mean on a density curve. So first thing I want to talk about, though, is there's 4 things you must do when you explore quantitative data. The first thing they're going to say is always plot your data. So if you don't know what the data looks like, you don't really have a great starting point, so plot it. The next thing you're going to do is look for an overall pattern and for any striking departures. Remember, in terms of like the SOCs, we said look for any outliers or gaps in the data. Third thing, you're going to calculate the summaries to briefly describe the center and the spread. So once we have the center and spread, again, we plotted it and we got the shape. And then the last thing is sometimes the pattern of a large number of observations is so regular, it's going to become smooth. So if you have lots and lots of data and you start making like this dot plot of the data, let's say when you graph it out, you have this dot plot. If you have lots of data, what will happen as you get more and more information, you start to come up with a smooth curve, and that's actually called a density curve. So if you hear density curve, it just describes the overall pattern of a distribution, and it typically is the area below the curve and above the intervals of values that are going to be on the horizontal axis, and it's going to be proportion of all the observations that fall in that interval. And the area of this is exactly 1. So a really good example of a density curve, it just looks something like this. And they're basically saying that we're looking at all the data below this curve, but in between the axis, the entire area of that is 100% of the graph, or 1. Now, when would you use a density curve? Well, we're going to use density curves for the rest of the book, basically. And you're going to use it to interpret areas under a curve. So they might want to know what is the area under the curve from maybe just this little sector. Okay, why would you use the density curve? And that is to estimate the relative frequencies. Remember, relative frequencies are just percentages. So if you want to know what percent under the curve, you're going to look at a density curve. Now, where is the median of a density curve? The median is going to be the point with half the area of the curve to the left and the remaining half to the area on the right. It happens right in the middle of that curve. Where is the mean? The mean is the point at which the curve would balance if made of solid material. So almost think of like a teeter-totter. If a teeter-totter were to balance, where would the mean happen? Sometimes the mean and median are very close to each other, and sometimes they are not. So right here in this example, we have a density curve. It's a very smooth curve. This green area in here is the area under the curve. It totals 1, and it goes up into the axis here. First question, explain why this is a legitimate density curve. Now, the thing that makes this a density curve is that the curve is positive, so it's above the axis, and the area equals 1. So that's very important that we have the complete area of this curve. Question 2, about what proportion of observations lie between 7 and 8? So if you look at the graph, this is observation 7 and 8. This darker green surface tells us that the area is 0.12. So what proportion, what percent? It's 12%. It's literally that easy of a question. Number 3, trace the density curve and mark the appropriate location of the median. Where do you think about half of the data is going to sit on here to the right and to the left? Now, if you look at my drawing, I think the median's about right here. So about 50% of the data is here to the right and 50% is here to the left. Okay. Number 4 wants to know, mark the mean. Now, look at this observation here of the distribution. This is skewed left. So do you remember in a skewed left situation, what do we know about the mean and the median relationship? In this case, the mean has to be lower than the median. So the mean would be somewhere to the left of that. Again, it is skewed left, so we know the mean in this case has to be less than the median, and we could estimate in our drawing where we think the mean would fall.